and this is just a wrap-up video for week 3. Some terminology that's also in the textbook is this idea of smooth, and it's just that if the velocity vector exists and it's not the zero vector. So pretty easy definition. Just be aware that, traditional ideas of, cusps and gaps and etc. Are going to violate this smooth principle. Okay, and so if there's a smooth parameterization, then we say the curve is smooth. There are derivative rules for n dimensions. A couple of them are mentioned in your book. The ones that I'll write, a couple of them here. The first one is if we have the derivative with respect to time of the dot product of two vectors. And I'll just say that these are both functions of t. I'll include that. X of t dotted with y of t. It's a lot like what you would think. It's just going to be x dotted with y prime plus x prime dotted with y. Okay. Now there is a similar thing for the cross product. Okay, so cross y of t, and remember with the cross product, the order does matter here, so just be careful with this a little bit. This is going to be vector x prime cross with y plus, and then x crossed with y prime. Okay, and again, these are in the textbook, so feel free to reference them as needed. Okay, this section is also in the textbook. It has a lot to do with Kepler's, or has a lot of information to do with Kepler's laws of planetary motion. So very interesting to read if you're into that. So I was. So please read those. And then the last little note I have is just about finding tangent lines to a curve. So if we think back to 2D, again, just for a minute, and if we had a curve, alright, we found the tangent line by saying, okay, well, if we wanted the tangent line, we needed to know the point, and then plus a slope times x, roughly, right? Now, in 3D, that same image of having a curve like this, okay, if I want to find the tangent line at a point, let's call this x of t naught. Okay, let's try this again. Alright, erase that all out. Let's call this x of t naught. Okay, we're going to need certainly the tangent vector, and I'm going to call that x prime of t naught. Okay, and so our tangent line is certainly going to be, so line, tangent, alright. We're going to have to begin with that point, so x naught, or x of t naught. Okay, I'm using notation that we use later in the course. X of t naught, and then to that we need to add some multiple of the slope, just as we did back in the 2D case, right? So we have a multiple times the slope. Okay, so the slope here is going to be the derivative vector, so x prime at t naught, and then we're going to multiply by a multiple, which is t. Okay, and then t is within something. We'll have to verify that. It could just be r, it could go in both directions, but make sure to pay attention to that in the problem. So those are the wrap-up notes I have for this week. And in class, if you need some help with getting GeoGebra installed or doing any of the visualizations in GeoGebra, we can certainly talk about that too.